everyone. Today we're going to talk about implementing optimization solutions on Databricks. This is Bryan. I'm a senior data scientist at Effectv Comcast. Today we also have Jivitesh, our lead ML engineer at Effectv Comcast, with me to talk about these topics. So today, agenda is going to start with introduction of ourselves, and then we're going to talk about what we are optimizing, how we are optimizing it, and some of the challenges that we face, and how we tackle these problems on Databricks. And then we also explore a little bit the crossover between data science and the operation research field. And then lastly, Jivitesh will talk about the architecture, how we utilize Databricks. So first off, what is Effectv? What does we do? So Effectv is the advertising sales division of Comcast. We deliver linear and digital advertising to help the advertiser reach their potential customers. We work with brands and agencies of all sizes to plan and execute campaigns, specifically tailored to their goals. So we first identify the right audience, and we would plan campaigns to reach those audience, and then we would report on the performance and also try to tie the campaign impact to the business outcomes. So we as data science team, we use data science and machine learning to empower the organization with data-driven solution to support this approach. So our team support on these four main domains. So for example, the first one, customer, we work on retention, try to understand the risk of clients turning away, and also we work on entity resolution. How do we identify duplication in our records? How do we simplify some complex hierarchy between the entities? Also, we have worked on creatives. These are usually advertising videos that we do, video processing. How do we do object detection, some categorization for the videos. Also, in the supply side, our supply is mainly our viewership and our ad inventory. So it's crucial to understand the viewing pattern so we can help plan effective campaigns to reach the right audience. We also support a pricing model, understanding demand and supply that could yield a optimal revenue. In the measurement space, we have like the big metric would be impression, reach, and frequency, because we need to report how well the campaign went for the client. And usually we need to do it in a cross-screen circumstance, because nowadays people watch content everywhere, on their phone, laptop, television, game console, like everywhere. So there's challenges like identity resolution, missing data that we try to use machine learning to help with. Also in the audience space, we do segmentation, we help client find lookalike segments, and we've also studied the incrementality of campaign impact, because sometimes you don't just want to target people who are already likely to be engaged with your brand, but also target people who were initially less interested, but became much more interested in your brand because of your campaign. So in other words, it's like the incremental conversion that we're trying to study. So tying back to our topic today, so what we're optimizing. So here are some of the general challenges in advertising. So there could be allocation problem, like there is finite inventory and demand. How do we improve our inventory utilization? Also, how do we help our client plan campaigns to reach their goal within a budget? Also, there could be a matching problem. For example, ad scheduling, we could have millions of ads and millions of commercial break that we can insert into. How do we decide, how do we assign which spot to which time slot, what network, what video, what area type of deal. Also, some problem could be formulated into some like a routing problem. So imagine like for a specific campaign, and then in a linear timeline, how do we place their ads at different point in time so that they can maximize the reach? And then also, how does different patterns of customer touchpoint affect their conversion? So when it comes to how to optimize, we need to evaluate a few things to make the right choice for the optimization problem. So there are some exact algorithm that that aims to find an optimal solution. To be a exact algorithm, the optimality needs to be proven. But it may be computationally expensive, and sometimes it's just impractical for large scale problems. And on the other hand, we have heuristic, which is sometimes a more practical method to find a solution because it is generally faster, but it does not guarantee an optimal solution. Usually it's sufficient enough to for an immediate goal. But actually, in practice, both could be combined to solve a problem, like using heuristic to help speed up finding a solution for a exact algorithm. So recently, we have a bipartite matching type of problem. So we chose the mixed integer programming approach, which is a classic and powerful optimization technique from the operation research field. Because it's very straightforward to formulate this problem, where we can just set the objective variables and capture the constraint, and the solver will handle the rest of it. Also, the optimal solution is needed because a very slight improvement means a lot of revenue. And again, the optimality can be proven here. So the gap between the optimal solution and your current best solution can be quantified, which means you can have a more logical way, systematic way to search for solution until an optimal solution is found or a just good enough solution is found within a reasonable time. However, it could be very expensive, could be slow for some large problem sets. So since it's slow, so we find ways to try to improve the performance. First thing, we could try to decompose the problem into subproblems, as many as possible, to solve them in parallel. This is where we leverage the Spark distributed computing system. The subproblem, you usually have to make it mutually exclusive across subproblems. That way you won't sacrifice the final objective values. And then you could, when it comes to software selection, you could consider a commercial one or an open source one. The trade-off is usually between the license cost and the speed performance. Commercial software is usually faster because of they have developed a lot of state-of-the-art algorithm within it. They simply usually have a better heuristic within it. And different software offer different parameter tuning For example, you can say terminate the search process until a time is reached or until a quality is good enough. Some software also support some callback function and some handlers to have final control during the search. For example, you can change strategy within it. You can add cuts. You can focus on different things within the search process. The last one is about machine learning, how we can use it to try to speed up the mixed integer programming. There are a few ways to do this. For example, you can try to run the mixed integer programming for historical data, and then use that to learn, apply a machine learning model to learn the pattern of it, and then try to predict a warm start for the next problem that come with a similar data distribution. That way you could possibly remove redundant variables and so that reduce the search space to make it faster. Here is how we do it with Databricks. So first off, we use PySpark and also those higher orders functions to generate permutation very efficiently because we want to avoid using any user-defined function because they can be potentially slower. Try to stick with the most native syntax with Spark. And then we apply some business rules to try to minimize the input size. And then, like I said before, we use a trained machine learning model to predict warm start and remove records that are likely just noise to the MIP solution. And then, so we leverage the applying pandas in Spark to invoke individual Python processes to build a mixed integer programming model and solve it. So internally, the Apache Arrow will transfer each group data as pandas instance, and then we build a mixed integer programming model off of it, and then we add variables, objective, and constraints. And then we solve it, and then collect the result from each of the group back to a Spark data frame. And then we've done some post-processing, format the result, and deliver it to the downstream system. And also we have a side pipeline to train the machine learning model to learn, to update the learned pattern from the output so that we can predict a good warm start for the next process. Yeah. This is a little bit more interesting topic about the intersection between data science and operation research. So we try to incorporate machine learning into mixed integer programming. So there are a few ways that we can try to integrate them together. First off, you can try to formulate a machine learning model as an objective or constraint to add to the model. So basically, you are turning your machine learning predictions into optimized decisions. And the machine learning model that is linear or can be linearized can be easily added to the linear programming model. For example, linear regression, linear layer, and the ReLU in neural network, because ReLU is just a max function of it and can be linearized. And tree-based model can be also linearized using some indicator constraints. Model with nonlinear function is also possible, but it just make it a non-linear program and it's just harder to solve. The second way we can tie them together is to use machine learning to pre-process the input, like we did to our problem. We use machine learning to further reduce our input size, reduce the model size to make it faster. And the last one is the most interesting to me. There are research papers to study how to use machine learning to actually improve the algorithm to solve a mixed integer programming. People would use deep reinforcement learning, graph neural network to try to learn a better policy to solve the mixed integer programming. Because in the current software, the out-of-the-box algorithm are usually for a wide range of application. They're not tailored for your specific case. So learning a application-specific policy to branch and bound or cutting plane selection that could potentially accelerate the solve time. So besides using machine learning in mixed integer programming, we can also try to use mixed integer programming within the machine learning application. So for example, in a online or a non-deterministic environment, it is challenging for just a pure mixed integer approach. Because data are arriving sequentially, and decision must be made at that moment. We won't collect all the data at once. We won't be able to do that. And there is also unknown future data. So in hindsight, we can try to use mixed integer programming to optimize the decision for the past events. So in a supervised learning scenario, we can use the results as label to train the machine learning model to try to try to predict a good decision for the scenario. And in a reinforcement learning setting, we can use the optimized results as like a benchmark to try to evaluate your learned policy, like how well the policy you learned from the reinforcement learning, because the benchmark would be the best you can possibly get without any uncertainty. And the learned policy account for uncertainty, so you cannot do as good as like the one that with MIP. But the learned policy is going to be applied in real time. And then I will hand over to Jivitesh to talk about the architecture.
Thanks, Bryan. So like Bryan talked about like how different types of MIP solvers are there and like how we can integrate machine learning with it. I'll talk about like how do you use Databricks as well as how we use the platform there to like enable certain services here. So starting with Unity Catalog governance, right? So like we have this data all sitting in Unity Catalog, and it becomes a one-stop shop for like giving access to people, storing this data in like managed tables as well as external locations. You can also have your machine learning models being tracked as part of Unity Catalog, and you can have monitoring as embedded within it as well, right? So all this part, like it helps us in like maintaining, we can have a governance team, we can have a data engineering team, machine learning and data science. All of us can collaborate here. Similarly, like you can also give information about compliance, like when was this thing last accessed? Is it being like updated? Are we following certain regulations and like internal Comcast best practices? So a lot of that thing can be tracked using this platform. We can also integrate this particular platform with like external data sets and also like data sets that we have generated internally. All this data can also be accessed using your the clusters, or you can access using like SQL warehouse or SQL endpoints, depending on how you wanna like structure your data set. So it becomes very easy for us to like manage this thing. And at the same time, like you can go deeper into it, like Unity Catalog actually goes to your account level, and then you can also do like a much granular access at your workspace level as well. So these are some advantages that we saw with Unity Catalog. within Unity catalog, right, you also want to look at like how your data is structured, how your models are structured. So these kinds of things really come into handy. So for instance, you would want to like put your data in this medallion architecture, which is like gold, silver, and bronze. And for most of your machine learning and data science use cases, you want to stick to the silver or gold kind of layer because it's much cleaner data. You don't have to spend a lot of time just like analyzing, processing this information, and it can be directly integrated. So that's for your data. Then you have your data, your models as well, right? So when it comes to your models, the system gives you a flexibility to like track your models, track volumes, or you can store your feature tables. You can also have like functions now. So all these things basically help you in like being more like in reducing your repeated programming efforts, having single place where you can manage things, and you can also connect to structured and unstructured data using volumes. These things like add up as you basically implement your system. And then like you can replicate the system across your different workspaces. That includes your staging and your production workspace. Typically, your staging and production would be similar in nature, but in your development workspace, you would want to leave gap for testing new features and like and also like giving room for different kinds of structures. But once you have set your structure for catalogs and a lot of these different things based on like whatever heuristic you're using, it could be your domain related stuff or your business units, you do not want to change that thing afterwards. So in terms of like the optimization problem, all your data would be somewhere in your gold and the silver layer of medallion architecture, and your models could be, the machine learning models can be stored here. But one caveat is like you can, there are certain like optimization algorithms which we cannot store directly in MLflow. So for that you have to have a workaround, use your cloud provider or something and store those models there. And then you can read that data or model back in, and then you can do that thing. But it's very good for like storing any kind of machine learning kind of model. Moving on, so you have your data now. Now, how do you build your applications, right? So this is the classic structure of like how you would want to like structure your development process, which starts from your development workspace, then goes to your staging workspace in the bottom, and then finally to your production workspace. You could see like in the production workspace, you have a box for MLflow. It's not just in production, it actually is for other workspace, but just for clarity, we had just put it down in production. Coming back, in the development workspace, like the name suggests, it's where you want to develop most of your applications initially, where your data scientists would be developing optimization or other machine learning algorithms. Then you would want to test them in your staging environment or workspace, and finally deploy them in your production workspace. Now, when you're developing these applications, it's best to have some kind of source control tool, and which kind of integrates also with your CI/CD tool that you have chosen. And this would basically enable all the backend thing to be taken care of, and the data scientists don't really have to worry about all the moving parts or the DevOps part of this pipeline. When it comes to like your CI/CD, right, there are many things that you want to like consider, right? Especially like when you're working with data, you want to like if there are any security concerns, like how you are using certain libraries, are you using open source libraries, or like Bryan said, there are certain like proprietary tools. So how do we go about scanning your code sometimes? So you would want to have some kind of code scanning ability. Similarly, you would also want to have some kind of secret store where you can store some of these like pipeline configurations or YAML files into a central repository. So those come into handy. And when it comes to the CI tool, Databricks does offer like infrastructure of code deployment. So you want to consider one of these tools when you're deploying your applications to Databricks. And again, like when you're deploying applications, there are different ways of deploying or packaging your node. It could be notebooks, it could be wheel files, egg files, or it could be like a PySpark command. So depending on what your way of deploying it and packaging it, you want to also consider like an artifact store product, which basically tracks and versions all these things. So you would have to consider a lot of different things when you're building this end-to-end pipeline. Similarly, like in the production thing, going deeper into the ML flow part, you could have a lot of like improvements in like how you're scaling your model from your deployed model to your staging model to your production model. And all this can be integrated with your webhook systems or notification systems just for if you want to track them. One caveat being like if you integrate some of the ML flow capabilities don't come as it is into Unity catalog, so there are certain exceptions and limitations, and you may have to refer to like where you want to really store your ML flow models. It could be in your like DBFS systems on Databricks, or it could be on Unity catalog. Moving on, like when it comes to data, like we also want to look at other things, which especially like data drift monitoring and model drift monitoring. Both of these are critical when it comes to like quality of your models and outputs that you're giving and how you're using your data for like retraining your models. Especially like if your data is spread out across different systems, not everything can be in Unity catalog. It could be somewhere in cloud, it could be on-prem. You would want like a data observability tool that other data teams have access to, especially the teams which are originating this data. And you can track a lot of metrics there. You can set your monitors, like if anything goes wrong with the data, changes in distribution, cardinality, all that thing can be tracked by the data owning team. And once that data is clean, it's approved by our governance teams, it actually goes in, most of the data may go into Unity catalog to be consumed by our analytics, data science, and other teams. Once it's in Databricks, right, there are different ways of tracking this. Like we would, like if there is any problem in the data, there's a concept called a circuit breaker. So any pipeline that you have, like your machine learning training pipeline, your optimization pipeline, will check the state of this particular data on this platform. And if the data is stale or if there are issues, it will not proceed with the pipeline. So the circuit will break there. On the platform, again, that you can track your data quality using lakehouse monitoring as well. Again, this gives you a lot of capabilities of like how your model is performing, especially like changes in distribution. But this is very specific to the Unity catalog assets. We would recommend if you can use this thing for your machine learning, like training data that you have developed there, so that you don't have to go back all the way back to your source data. And similarly, when it comes to model drift, you can build your own custom pipelines or their workflows where you can track this thing, or you can use certain capabilities of lakehouse monitoring for all this. It's also important that you just don't identify the issues, but also communicate using different channels. It could be your ticketing systems, it could be your notification systems, like communication systems in your organization that you want to communicate. So all these different concepts are really essential when it comes to like building a system. Again, recapping, we went through like data being stored in Unity catalog, governance layer there, and model governance there. So then we moved on to the CI/CD process, like how you want to build your pipeline, engineering processes, and finally the data monitoring aspect, which is very important for your overall model health. So with that, like I would just, we would like to conclude our talk. We still have some time, but on our team, we are hiring, and these are some places that you can reach out or apply for roles. So again, you can connect after this call. Thank you.